Welcome to a lesson with Dr. Powell. Let's take a look at how we can raise an element of a group. So take any element in a group, in a finite group, and let's suppose that this number of elements of that group is n. Then g to the end is always going to be the identity of the group. I'll just call the identity 1, thinking of multiplication, but it really could be any operation. So why is this true? Well, first of all, the elements of G, well, take an element of G, and look at its powers. G, G squared, G cubed, and so forth. This set actually makes a group. I mean, this is finite. G is finite, which means that this list has to be finite in itself. So it has to wrap back around on itself somewhere. So some power has to be equal to some other power. Well, and it's assuming that n is less than m perhaps, what happens if we take the inverse of g n times, I'll notate it that way, and put it on both sides. They're on the right, but here I'd also have to do it on the right. Notice that this just becomes the identity. Wow, which means in particular, this is gm minus n. One of these powers is actually the identity. And you also have inverses in the group too, because you have inverses in the group as well because of this. Because let's suppose, for instance, that you know that g to the k is equal to 1. And let's suppose that a and b are less than k. Then GA and a plus b is equal to k. Then GA times GB is equal to GK, which is equal to 1. So clearly we have inverses. This is a group, all the powers of G. We just will call that the subgroup of G generated by little g. So that is a subgroup of G. Its cosets are all the same size. So that in particular means that the size of this group times the number of cosets because the cosets partition G is actually equal to G itself. Wow. So wait a minute. The number of powers of G is actually a factor of G. Oh my goodness. Let's see. Well, the number of elements of G, let's just think about that for a minute. How many are there? Well, it starts out, let's start with 1. And let's go G squared. Let's go up to G R minus 1, where R is maybe the number of elements, is the size of G. So R is equal to that. Wait a minute. Well, that means in particular that G, well, the next one wraps around a 1. Hey, and the next that's G to the R. G to the R is equal to 1. Wait a minute, R is a factor of n. So Gn is equal to Gr times something. And this part's 1. So 1 to anything will just be the identity again, 1. So yes, it's true. Whenever you have G raised to the power of the group, or the number of elements of the group, you're always going to just get 1. Thanks for watching.